Good day. We're going to look at hydrogen bonds in two videos. In the first video, I'm just going to have you go and fill in the blanks in your notes. In the second video, I'm going to show you how to sketch hydrogen bonds in hydrogen fluoride. You might have noticed I tried to make some bonds there in the word bonds just for emphasis. Fairly impressive. Water has a low molar mass, and by now you know that's 18.02 grams per mole. And what this means is it should be a gas at room temperature, that the molecules are light enough they can fly away from each other and evaporate. That would be a big problem for life on Earth. You think of things that require water. We have oceans, we have lakes that are liquid because of hydrogen bonds, but also even things like your blood and whatnot. So life on Earth would have a lot of problems without hydrogen bonds. So water has a relatively high boiling point. That means relatively high considering its molar mass. And what this means is there must be extra stickiness between the molecules of water. And that extra stickiness is due to what's called hydrogen bonding. So first of all, hydrogen bonding occurs when hydrogen is bonded to one of those four highly electronegative elements. And those include fluorine, chlorine, nitrogen, and oxygen. The electronegativity difference is so great that that other atom pulls the electrons away from the hydrogen atom. And what's special about hydrogen is it will only have one electron. So if that electron gets pulled away, what's left? The proton. So we end up with a fairly strong partial positive charge, and there's our delta positive. So if it's delta positive, then the other end is going to be delta negative. And this is what it's talking about. It's very small, has no other unbonded electrons to interfere, no inner shells of electrons. The nucleus gets exposed and the proton gets exposed. That's what we're talking about. And this is an important force. It's roughly 1/10 the size of an ionic or covalent bond. So here how it's sketched between 5 water molecules, and we'll do the same thing on the next video for HF. And what you see is the oxygen is represented in red, and that's not surprising. It's going to be bigger than the hydrogen. So here's our space-filled molecule. And what happens? Here we have a water molecule. This is partially negative. So it's going to orient towards one of the hydrogen atoms, and the dotted line here represents a hydrogen bond. Now over here we have the oxygen, it's partially negative, and it's going to cause that hydrogen to align in such a way that we have the opposite charge and we get that extra hydrogen bonding, the stickiness. And you see that's what it does. The positive part of one molecule is going to be attracted to the negative part. And so we have shown 5 hydrogen bonds here. But of course these water molecules could affect each other as well. So this might be attracted to the oxygen, and this oxygen might be attracted to that hydrogen. And overall, that's the extra stickiness that we get with hydrogen bonds. So we've already talked about how it keeps water liquid at room temperature and pressure, or even the Earth's surface atmospheric temperature and pressure. For DNA shape, we know it's part of the zipper. It's what allows DNA to open up and then reconnect. Those are hydrogen bonds in between those nucleotides. And protein shape. When you take biology 12, you're going to learn about protein, and you're going to learn one of the major roles in the human body for protein is as enzymes. And these are chemical catalysts. What that means is they speed up reactions without being used up. And a lot of time it's their shape is what matters. They'll have a specific shape, and something called a substrate will come in that will fit in a lock and key mechanism. So if the protein shape is correct, then the substrate comes in, it's held in position, and then reactions can happen. It makes it easier for those reactions to happen. And then the products can move away, and then the enzyme can work again. But of course for proteins, if you heat them up too much, they denature. And that means you've heated them up that you overcome the hydrogen bonds and you destroy the shape of the protein so it no longer functions as an enzyme. So that's a little preview for Biology 12. Bon appetit.